KEET TV presents Homework Hotline, the after-school show that fuses learning with fun. Watch local teachers bring the classroom on air and online. This is Homework Hotline.
Hi, welcome to Homework Hotline. My name is Dan Scofield, and I teach science at St. Bernard's Academy.
And my name is Rita McConnaughy, and I am a math specialist with Northern United Humboldt Charter School. And you're watching Homework Hotline. Thank you for coming.
Thanks for joining us on Homework Hotline today. It is May 5th, so happy Cinco de Mayo.
Happy Cinco de Mayo. That's awesome. And yesterday was another special day. It was May 4th.
May the 4th be with you.
May the 4th be with you. Did you dress up Star Wars? Anything?
Didn't.
No.
I was boring this year.
Boring. Okay, well, I saw a lot others out and about.
Lots of people out and about in May the 4th be with you gear.
Speaking about out and about and going in circles, we're going to talk about something called the unit circle today. It's one of my favorite things, and it's to talk about, especially in my Algebra 2 classes, pre-calculus classes. So if you're watching this and you're not quite in those classes yet in high school, we simplified the unit circle for you. There's a lot of simple parts to it. We're going to talk about the radius of a circle. We're going to find degrees, a new thing called radians, and we're going to talk about coordinates. That's where you graph points. There's a lot of different trigonometry connections, and we're not going to get as much into them, but look at that list. Construction, plumbing, engineering, air flight navigation, GPS, video games, and carpentry work. And I bet the list goes on.
Yeah, saw blades have circles, don't they?
What has circles?
A saw blade.
A saw blade has a circle too, yes, definitely in construction. Okay. So let's get started just with a thought. Where do you see and use circles?
Radial saw.
The radial saw. You mentioned an eyeball. There's circles there. Circles when we're driving. We may turn in a circle or come back.
Steering wheels have a circle.
Steering wheel has a circle.
Wheels have circles.
Wheels have circles. On every circle, there's always a center. Okay, so a center is always the same, or not the same, but every circle has a center. And then every circle has a line. It might be an imaginary line, but it goes from the center to the outside of the circle, and that is called the radius.
It's like a spoke of one of your bicycle wheels, right?
A bicycle wheel, yep. A spoke is just that from the center to the outside of the wheel, helps hold the wheel out so it doesn't collapse. Okay. How about the distance around the outside of the circle? That's a special word.
Circumference.
The circumference. Okay. So we see circles a lot. We use them a lot. If I was going to use a paper plate, eat on that, that's even a circle. Okay? And actually we're going to use this particular circle and we're going to do an activity to create one of the unit circles.
Ooh, fun.
Yeah, really fun. Okay, so center, radius, and circumference. Keep those in mind. Okay, what makes the unit circle special? The radius from the center to the outside is 1 unit.
Okay.
What could the unit be? It could be 1
mile.
1 mile, 1 centimeter, 1 kangaroo, 1 zebra, whatever it is, it's 1 unit. Okay? So that gets to be really important. When we build the unit circle, we're going to have 4 quadrants, 16 angles, and a couple different XY coordinates. On the right-hand side here, it says unit circles can be used to define right triangle relationships known as sine, cosine, and tangent.
Okay.
That's pretty cool. And a quick reminder, a right angle is 90 degrees. We'll show that with your arm. Like, how do you make a 90-degree angle with your arm? Do it again so the camera can see you. Oh, yeah, so you do this. That's a 90-degree angle, a corner, right? Or give me an L, right? Okay, so different.
So coordinated here.
Wait, which way would it go? So if you look around, there's probably lots of right angles everywhere too, like corners of the screen makes a right angle, 90 degrees. You could kind of do it with your finger, maybe with your hand like this.
Yeah, there you go.
Or on this hand, I tried to do a 90-degree angle on my hand with my pinky and my thumb. Let's see if that shows up. Kind of have to keep, my thumb won't go straight up, but if I think here, 90-degree angle.
Okay.
All right. So on the circle, I want to make a 90-degree angle because that's going to be useful. Let's see, maybe I'll just write on here.
A little bit more fun.
Come on.
There it is.
Okay, so 90-degree angle, I'm going to go straight up. Oh, it didn't do anything. Hold on. Maybe, no, I can't write on there. Okay, so I'm going to use
Maybe
the marker. See if that's better. Okay. Oh, where'd that line come from?
that's one you drew. It looks like maybe you're gonna go from there. You go. That's good.
Okay, so 90-degree angle right here. All right, you never know if the technology's gonna work. So it's a little messy. I'm so sorry. Let me see. I'll just use a eraser real quickly. Try to take this part off. You know what? Maybe it's not like in my finger. Oh, that's way better. Look at that. Okay. So I drew another radius. Every radius on a circle is the same measurement.
Okay.
From the center to the outside. So this radius also has,
You're doing eraser.
oh, I'm on eraser. Thank you. This radius also will have a unit of 1. Okay. We're not going to spend a lot of time on this screen anymore, as long as I can get my thing back. Oh, it says the internet's trying to connect up there. See?
I see, it's trying to connect.
Okay.
Everything.
We may have technical difficulties.
That's okay.
Okay, we'll figure it out. One little note down here I said is that triangle geometry, that's how that helps me remember that it is trigonometry.
Triangle geometry.
Triangle geometry,
It's trigonometry.
trigonometry. So I don't know if everybody makes that connection, but that's how I remember, like, trigonometry. What's that about? There's triangles. Okay, so if I can't go to the next screen, oh, I
like
can. That's wonderful. Okay, are you ready?
I'm ready.
Today, Dan is our one man. Okay, this is called a unit circle because the radius is
1.
1. The radius is 1. So let's keep that in mind, that the radius has a measurement of 1. To build the unit circle, we're going to have 4 quadrants. Okay? And quadrants will start.
I think over here.
Yep, come over
There
here.
you go, good.
I think I want to stay on black. Okay, quadrants will start right here as the first quadrant. Then should I go clockwise or counterclockwise?
Depends.
Depends, I know.
I mean, it's weird that you go counterclockwise on this.
Yes,
It is
we
weird.
do.
I think it's because both of them are positive y. Is that why? I don't know.
Yeah, I would think so. So here, over here is quadrant 2, and I'm using Roman numerals. Trying to write them well.
Northern hemisphere bias, I think, maybe going on.
Maybe, no. I think partially is because when we talk about the angles, it would start at 0 degrees here and then go this way and turn.
Yeah, positive rotation is always considered to be counterclockwise. So,
Yeah.
That's just by convention.
Okay. So quadrant 1, quadrant 2, quadrant 3, and then quadrant 4. And usually we write it as Roman numeral.
IB.
IV.
Excellent.
Okay, 1 before the 5, Roman numeral 4. Okay, so start building a unit circle with 4 quadrants. We're gonna do this on the paper plate.
Ooh, how fun.
So I gave you a paper plate.
Okay.
The best way to find the center of a circle would be to fold it in half. So you wanna
Okay.
fold your paper plate in half, matching up the sides, make
do
a
that.
nice crease. Kind of like paper folding, but
All
paper
right.
plate folding. And then because we really want that new line to stand out, you're gonna grab a black marker
All right.
and try to draw that.
Draw a straight line down it?
Yep.
All right. See what kind of line I can draw. You know, I'm gifted this way.
You are.
My lines are always fun. Okay, here we
Even
go.
if you're not gifted, you can practice. It
That-
doesn't have to be perfect. It's
That
okay.
is definitely not perfect, but it's pretty good.
I usually say
not
the
so-
land of math is exact. We want to be exact with numbers if we can, but the land of science and construction is the land of close enough.
That's right. Never exact.
Right. Okay, so how will we figure out the exact center the best we can?
I think we could fold it anywhere else, and then if you fold it anywhere else, it's going to intersect on the circle. But I think we want to have 4 quadrants, right?
Yes, so if we want to do 4 quadrants, try to put this point here on top of this point over here.
Okay, that's what I'm going to do.
And I'm going to make those points just a little bit bigger on my end. So that,
If I fold it like this, does that work?
yeah,
Okay.
yep, there's your 4 quadrants. So you fold it in half and then half again.
I think I'm going to do a better job on my line this time.
Yeah, you just got to get a good crease. If you get a good crease, then okay. So we've got our 4 quadrants, also known as 4 slices of pizza, perhaps.
Pizza.
4 pieces of pie. More places circles are. Food.
Oh, yeah, that's right.
Do you like
Pie.
circular food?
How long you're putting points on there? Okay,
Yes. Yep. Because the points are going to be where we have quadrants.
All right.
I'm not, sorry, quadrants. Coordinates.
Okay.
Okay. All right. So we've got our 4 quadrants. Let me see what the next slide. So now we're going to talk about turning. And when we turn, we usually turn certain degrees.
Right.
Okay? So if I'm standing in the center here, in the center, and I turned before 90 degrees, oops. Let me see here. I don't know why it made a nice line. Oh, I know why, because I'm using my finger. I gotta use the marker that goes with
Well,
it.
that one did pretty well. The
Yeah.
last one did fine.
So turning 90 degrees,
Okay.
if we made our 90-degree angle, but there's more angles marked on here. And so we're gonna look at just quadrant 1 first, and I have a nice hand up here on the picture, and if you notice on the hand, I could try to draw that 90-degree angle again, right here, okay? You can kind of see that black line show up. Let me pick a different color, maybe red. What happens when I draw a line from this corner, or the vertex, up
Right up the
right
middle.
down the middle of the hand?
That's like 45 degrees.
45 degrees. So I do this in class usually. We'll see how it shows up on the camera. But I'll try to draw that 45-degree angle.
That looks pretty good.
Let's see. I think I have to be this way. There we go.
Nice.
Okay, so who knew your hand had a 45-degree angle on it?
An angle measure.
Has, not only does it have a 90-degree angle, but that 45-degree angle down the middle. That's pretty cool, huh?
That is pretty cool.
Okay, well, what about the other 2 fingers? They're kind of lonely, right?
That's right.
So they're going to feel left out
But that looks like a third of the way up for each one of them.
a third of the way. I don't know if I can hide this one, but yeah, it's kind of strong. It wants to go out. But if I were able to hide it, it would be like cut into 3 equal pieces of pizza, right? Or slices of pizza. And so that's where a 30-degree angle and a 60-degree angle come into play.
If that was 0, that would be 30, that'd be 45, that'd be 60, 90, okay.
So on your hand, let me use a nice different color. As long as I don't sleep like this, we'll be okay.
I was going to say, what kind of soap do you use to get that off? This is permanent marker.
Okay, so my 30-degree angle, does the orange show up on camera? No. We'll try blue. Oh, it does show up? Okay. And then, so there's my 30-degree angle, my 60-degree angle. Who knew on our hands, not only can we kind of do a 90-degree angle, a right one, a 45, which is right in the middle. Don't move my pinky down, huh? Okay, but there's also a 30 and a 60 in there.
Nice.
Isn't that cool? There's a couple more, which I think is kind of cool. There's also a 15-degree.
Oh, between the middle finger and the...
Yeah, between your ring finger and your middle finger, or your index finger and your middle finger there. So, if you ever see someone and they're out and about and they're like this, you know, like looking off in the distance with their hand there, maybe they're trying to do a 45-degree angle or something like that.
Figure out the slope of something if you did that.
Okay, so
pretty fun.
No extra charge for that. Just kidding. All right, coming back to the angles on the unit circle, we can do the 30, 45, 60, hit the 90, and then if my hand is rotated, I have another 30 degrees past 100 or past 90, which is 120.
Okay.
The middle angle
is
right
90 plus
here,
45.
90 plus 45. And I'm going to show it on here that would be starting at what we call 0 degrees. Boy, that didn't show up very well. That wasn't a nice turn.
I mean, it was, you drew it just great. It's just the screen took a bit to catch up to you.
Starting at the 0 degrees here, turning 135 degrees would be the middle on this side, which is 135. Okay, so when we put this onto our paper plate, we're actually going to use right triangles instead.
Okay.
So we're not going to come back to the paper plate just yet until we get to special right triangles. Okay. What happens when we go all the way around the circle? Like we start here and we turn all the way around. How many degrees have we gone?
That means that if I jump up in the air and I spin completely around and face you again,
how many degrees have I turned?
That's a 360.
That's a 360 degree angle.
I don't think I can do that, but I'm not even going to try.
Starting here, let's see if it'll work. And I turn 360 degrees. Okay, so it kind of got there.
That
So
worked okay.
that's why we have 16 angles up here. There's the 0 degree, and then the 30, 45, 60, 90, 120, 135, 150, 180. 180 degrees is a nice one too.
Because that's just facing the other way.
Yeah. Have you heard of like an about face, right? Oh, I don't know if I could do that. So the army, like you're facing this way and it says about face, and then you're like, chirp, and you turn the other direction.
Nice.
Okay, so that's 180 degrees. I get off topic. I think we're good on degrees, right?
Okay.
The angles. Okay, and that's a fun topic when you start learning about it. And if you already know it and can do it in your sleep, there's something called radians. This is something new that you maybe have never heard of it. Remember we talked about the circumference of a circle? Distance around the outside. There is a formula, pi times diameter. And I couldn't write the pi symbol, but pi, I'll try to write it up here, Greek letter. That's how I make my pi.
Looks like a little house.
Little house. Greek letter, it's a constant number, 3.14, 159, 265, ... goes on forever, never stops. Okay? If I want to use radius instead of diameter, every diameter is 2 times
The radius.
the radius.
Okay.
Okay. So, on our unit circle, what was the length of the radius?
It was 1.
1. Yay! So, it is the 1 unit circle. So, in this formula, instead of r for radius, I'm going to put a 1. That means the circumference, the distance around the outside of our unit circle, start here, travel on the outside, is 2, or pi times 2 times 1,
Which is?
otherwise known as 2, cut off, 2 pi. I think I have to write it in here. Okay. How about halfway around the circle?
1 pi.
1 pi. 2 pi divided by 2, because I'm going halfway. So at 180 degrees, turning 180 degrees, we travel on the circle 1 pi. And it's written right here. I'll just try to make it a little bit bigger. Now this is like traveling on the outside of the circle versus turning so many degrees.
Okay.
So that's why they call it radians. And we leave it in the form of pi. Remember I said math was the land of exact? Pi is the exact. And we didn't have to round the 3.14, 265, or, you know. Okay. Good?
I think, yeah, that's great. Yeah.
What if I go halfway to pi and I turn 90 degrees? How far do I travel on the circle?
Well, 90 degrees, or pi divided by 2.
Pi over 2. And so I know that looks a little strange, especially since I don't write it very well with this marker on here, but pi over 2. Now, I'm not going to get too much more into it because it gets a little pi crazy, and fractions can kind of be like blow your mind.
We only do that on March 14th.
March 14th, yeah, we can do that. But halfway to pi over 2 would be pi over 4, okay? And if I wanted to look at this, this is how I usually remember it. The 45-degree angles here. This is 1 pi over 4. This one right here, if I travel to the 45 or 90 degrees, is 2 pi over 4. Is that a pi or a 4? Okay. And 2 pi over 4 simplifies to be 1/2.
Right. Okay.
Okay.
Pi over 2.
And then here, 3 pi over 4. I'll just circle that.
Yeah.
4 pi over 4 is the same as 1 pi.
1 pi.
Thank you for the 1. 5 pi over 4 would be if I kept going, and it's totally okay to have an improper fraction because it's the exact and we can keep using it later on in other calculations. 6 pi over 4, 7 pi over 4. This one would also be 8 pi over 4. I don't know if I can write it, but what is 8 divided by 4? 2. Okay, so I get a little excited because I like doing this in class with my 11th graders. All right, we better get to this because this is going to help us do our unit circle. So if we look at these triangles here, they're special right triangles, okay? I say they're special right triangles because, like this one, the green one, it has 45, 45, 90 degree right triangle.
Okay.
Okay, so you're going to set it on here.
Well, this will make my 45-degree angle, won't it?
This will help give you your 45-degree angle. I'm going to show this one. So my green one, the green line, what was that green line?
That's the radian.
The radius of the circle, right?
Yeah, it's the radius.
And what's the measurement of the radius of the circle?
It's 1.
1. Okay.
On this circle.
On this particular circle, because we're calling it the unit circle.
Can I draw my green line?
Yep.
Okay.
Please do.
I guess, may I draw? We don't know whether I can or
Okay.
not.
And then over here, you could flip it and you have another 45-degree angle.
And that unit goes all the way out to the same place.
Yep. So the 1 would reach, the radius would go all the way out.
Whoops.
We could rotate it about the x-axis, have another 45-degree angle drawn. You're doing good. Okay.
I'm going to do my final one.
So unit circle, there's the angles, the radians, and then one of the things that we didn't get to as much is what if these are coordinates? If this is 1 on the x-axis, it is the point 1, 0. How about up here? It's
It'd be
0 on the x-axis, but it went up 1, so that's 0, 1. Okay? Special right triangles help us figure out what the coordinates of these points are all along here. Let's see. Help us figure out. So if we know this point and this point, this special right triangle, when you learn about that, it'll help you calculate this, because a 45, 45, 90-degree right triangle, these two legs are the same.
Okay.
And that would help tell us the x measurement and the x measurement and the y measurement of this point. Okay. I wish we had more time. Do you have a question?
Oh, no, I was just looking. That coordinate is a strange number. But
Okay. Something called SOHCAHTOA, sine, cosine, tangent. It helps you remember it. Like I said, I wish we had a little bit more time to go in depth. But if we look at, just like how you would use a multiplication table with your multiplication facts on it, and we use that a lot, like we memorize it. Well, guess what? There is a unit circle table that has all the measurements, all the radian, all the degrees, and all the coordinates filled in. And then it adds to it the trigonometry, sine, cosine, and tangent, and then some others. So often with my students, we use this unit circle table. Okay, there's some cool pictures. I think we have a couple minutes. Here's a unit circle 3D. We're wrapping it up, but oh, can't get it over.
all right, that's
Hope you
great.
had
All about
fun.
circles. All right.
Unit circle, a lot more we can do with it. I'll try to put some pictures up here. Thank you guys for joining in.